In this video, we're going to take a look at how to patch complex geometry with multiple side openings in Fusion 360. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to tackle something that we've already done several times, and we're going to talk about patch and loft. Now, if this is getting to the point where you never want to see patch and loft again, I understand, because neither do I. But honestly, those two tools, the patch and the loft tools, are going to be the ones you use quite often. Probably the most, if not second most, to things like ruled surface. So we need to talk about a couple of additional cases because in all the videos that we've done so far, they've been somewhat ideal cases. And by ideal, I mean we've had pretty much a rectangular four-sided opening or geometry that we needed to fill in with a surface. Now in those cases, we're comparing loft and patch. We're trying to see exactly which one gives us the best geometry or geometry closer to what we're sort of intending. But what we're going to talk about today actually came from a comment on the last video. Janos, and I hope I'm saying that right, but you can see the comment here on the screen. The comment was about how he learned to use loft for four-sided patches and the patch tool for three or more than four-sided patches. And I 100% agree with that, but there's a disclaimer there, as there always is. Now, not every CAD surface tool is built the same. There are certain CAD packages that deal with these problems better than others. Now, there are some, like SolidWorks, which I have to mention here, where you have tools like boundary fill and loft and sweep, and you have their patch tool, which can essentially overlap and do the same thing in a lot of cases. Their version of the patch tool allows you to have sort of an open section, an open selection, where Fusion, it has to be completely closed. All the edges need to touch. But I want to highlight a couple cases that go against the comment. Now, the only reason that I want to do this, and it's not to sort of disqualify it by any means, because I 100% agree. Loft, four sides, that's your go-to. When you're thinking about a three or a multi-sided patch, the patch tool in Fusion 360, since that's what it's called, it seems like the go-to. But the reason I want to do this video is because I want to talk about when those aren't the case. So if you want to follow along, you can go to the description of the video and download this data set. This was a form body that I created. If you want to see the form body, you can go in and you can take a look at how I did it. All the edges are there, the free form body is there. It's essentially just meant to represent something like a handle that you would put on a device. Who knows what it is? It's just a shape. But the reason that I want to use something like this is because we have these edges. We have these defining features in this complex shape. And these defining features sometimes need to get patches or surfaces to fill them in for whatever reason. Now, it might be because a section of the surface is bad. The geometry is not great. Or maybe you added some additional details and you need to sort of fix certain areas. So what we want to do is we want to take a look at the couple of cases that I have highlighted here. We've got a nice rectangular four-sided opening. We've got one with multiple sides. We've got one that was created with a spline that has curvature continuity all the way around. And we have a triangle. Now I want to take a look at both patch and loft in all of these cases, which might seem counterintuitive. And I want to highlight the sort of pluses and minuses or pros and cons of each in each case. Because there will be problems with both methods in all cases. Now, you're just going to have to deal with that. It's just the way that surfacing tools are working in Fusion 360 and honestly in a lot of CAD softwares. They're just not meant to do complex surfaces. So we're getting a little outside of the realm of what some of these tools are designed to do. We're looking at a form body, which is essentially a complex curvature continuous body, and we're trying to use these surfacing tools, which in my opinion are sort of a step below the form tools. So let's get started by filling in this area now that I've got all that talking out of the way. So the first one, pretty straightforward. We're going to use the loft tool. But before we do, let's take a look at patch and why we don't want to use patch here. So when we select patch and we select the boundary, note that I've got all the edges grouped. I'm going to say, let's use curvature continuity. Well, the thing that happens here is that nice, crisp geometry that we have is starting to get flattened out. And the reason it's getting flattened out is because the patch tool gives equal weight to all edges. Now, it's taking all the inputs, which is this entire four-sided boundary, and it's saying we want curvature continuity exactly the same everywhere. So for small sections, this might work okay if you've got a relatively small distance between the start and the end of this. But because we have a longer section, in this case, the rectangular section is longer, double click the mouse wheel, let's see. The rectangular section is longer in the area where we really need to drive the curvature. So what we end up seeing is that we get this sort of dimple or dent or this melt that happens right in the middle. For that reason, the patch tool just doesn't work here. Now, a keen eye might say, well, you had all the edges grouped. Why don't you just ungroup them and give it different weights? Well, that's where the patch tool starts to fail. If you get creative, and let's say edge 2 here, let's say instead of 0.5, we want to do maybe 1.0. What ends up happening is that it sort of just loses its mind. Now, if I change the 0.5 to a 0.0, you can see that now it fails. It was okay at 1.5, even though the result was kind of hideous. At 1.0, it just doesn't even produce a surface. Now, what I found with this tool, whenever you start to vary the weight of each of these edges, because they all intersect at some point, edge 2 is intersecting edge 3 and edge 1. Because they have different weights, it really doesn't know what to do in those corners. And that's why the Loft tool does a better job in situations like this. You can see originally when it was at 1.5, it actually did have this preview. When I went to 1.0, it just couldn't even figure it out. Now, this is obviously not a result that's good. So we're going to hit cancel, and we're going to take a look at the Loft tool. Now, when we're using the Loft tool, not only do we have to think about our inputs, we need to think about our selections. Now, we want to carry this curvature, that shape, across the surface that we're trying to create. For that reason, I want to make those edges that are touching that curvature my profile 1 and profile 2. Then these other edges, these are going to be my rails. Now, remember, with rails inside of a Loft tool, we can give them tangency and curvature continuity, just like we can the profiles. However, we don't have control over the weight, and there's good reason here. Just like we saw with the patch tool, Fusion is going to take care of the weight of those rails based on the stress or the tension in the surface. And you can see that we are able to carry that shape across. It looks as if the surface never even had a hole in it. It carries it across very nicely in that area. So now let's take a look at another example, moving our way down this part, and that's this multi-sided opening. Now, the comment, again, which I 100% agree with, is that 4 sides, you go right for the Loft. If it's 3 or more than 4, you go for the patch tool. But once again, I'm going to show why in this case, when we're talking about changes in curvature in multiple directions, where we're trying to carry curvature across a surface, the patch tool is just going to fail nearly every time. So let's try patch. Go ahead and select our surface. Again, we're connected because we know that driving each edge individually is going to cause problems. And once again, what you see here is that nice shadowing effect that we're getting, the highlight on the sort of upper edge of the surface based on where the light is. It starts to instantly flatten out and then come back up at that edge. If we go to our analysis tools and we take a look at the zebra analysis, from the top, let's go ahead and change the line orientation. We can see it very clearly here. The lines on this side are carrying across. The lines over here are sort of floating and sort of dipping down. I'm going to sort of take a look at this from another perspective as well. So we're going to cancel this, and we're going to just talk about the number of edges that we have. So we've got 2 over here, which are intersecting the curve that we're really interested in. We've got 2 over here. Now they sort of hit at different points at different angles. This side we've got 1 edge connecting them, and this side we've got 2 edges. So it's not even a nice even number that we can work with, but we still are going to use the loft tool to fix this problem. Now, I say fix, that's not actually the right way. To think about this is we're going to get as close to a good solution as possible. So we're going to say loft. We're going to take these two edges as profile 1 and these two edges as profile 2. Now, in general, whenever you're making a loft, and again, I say in general because there's no universal rule that tells you exactly which tool to use in exactly which situation, because it's always going to be based on the geometry. But in general, when you're creating a loft, you want the number of edges for each profile to be the same. Now, the closest I can come to making a 100% guaranteed statement here is that whenever your profiles are not curvature continuous, they're not an arc, they're not a spline, when we're dealing with lines that have some sort of angle between them, this is a pretty particular case where you really need to pay close attention to the number of edges. Now, this is going to be more important than if you had a curvature continuous set of edges. So if you have edges like this where they're just coincident or G0 continuity, then you want to make sure that they do match input profile to the output profile. Because we do have one connected edge over here, we can use that as a rail. And once again, we can use tangency or curvature continuity to drive the shape. Over here, we cannot use this as a rail. A rail must have a smooth profile, which means it must be curvature continuous. So that means we need to leave this edge open. We're going to change our profiles to curvature continuity. And because we do have this open edge, because we don't have rails everywhere, we're going to make sure that we're using aligned edges. Now, I did do a previous video where I talked about the differences between aligned edges and aligned to surface. In this case, it's not going to make a difference. So aligned edges or aligned to surface will give us the same result. But now let's go ahead and say OK. And you can see here we were able to carry that shape across, at least that's how it appears. Now there are going to be some inherent problems, but the way that we fix the rest of this is we stitch these together and then we use our patch tool to fill in that small section. I'm going to use curvature continuity because that's what we used on the rest of it. I'm going to say OK. If I use Control and 4 on the keyboard, you can see that it looks like it's less than ideal. There is some sort of ripple there, but I can guarantee you this is probably the best that we're going to get with these tools. The other option that we have, which is probably the way that I would approach this, is to create a better opening. So cut away more of the surface just to make sure that the inputs are better. So for example, I might create a spline cut here instead of having these two edges so that I could use it as a rail and build this with one loft. So that is another option. It's always a valid way to go. Next, we're going to take a look at this edge. And this edge right here looks just like one smooth curvature continuous edge, which is true. However, patch still has the same problems with this. If we are going to use curvature continuity or tangency, it's going to give the same weight or the same amount of influence everywhere, which means in this case, you can see that crisp, clean edge is again disappearing. This time, instead of getting flat, it's actually bulging up a little bit. So once again, we have the same problem that we had with the other edges. This is a little bit trickier to do with loft, but we're still going to take a look. Now, one of the benefits that we have in this case is that this opening actually crossed other edges that we had in the surface, which means I can go from here to, let's say, these two edges here, and I can make them curvature continuous and drive the shape. I might want to try to add to that profile, and you can see that it's starting to fail here. So what this tells me is that I need to rethink my approach. This is probably not going to work. In some cases, you can get away with this by changing the aligned edges, and it might be able to create a result. However, you'll notice here that aligned edges is actually going to make a difference because the aligned edges are taking a look at the edges on the surface. If we change it to align to surface, this is going to use the tangency or the curvature continuity of the surface that we're using rather than the selected edge. It still doesn't fix our problem, but it does get us a little bit closer. Some instances you might find that tangency gives you a usable result. It might not be the best result, but it does give you a usable result. And you might end up actually wanting to use free edges instead of trying to align them to the surface. So you need to play around with this a little bit, and this does still produce a problem that we're going to have to fix. So I'm going to say okay, and I want to note that we have a bad surface. This is not an ideal result. It creates this sort of ridge that happens in the middle of the surface. There are cases where we have to sort of make this a workable option, and the way that we do this is by trimming that away. So we're going to create a sketch on the top. Again, Fusion really likes to rotate these views even when I don't want them to. I'm going to use a spline, and what I want to do is I want to try and follow, which is kind of hard to see in this view, but I want to try to follow the curvature of that highlight spot. I just want to make sure that I have some sort of curvature there. In this case, we can use trim because we're dealing with this one surface. Select our trim tool and the little area that we want to get rid of. I'm going to stitch these together. And then we can use our patch tool to fill in the rest of that. So once again, this is a great way for us to use the patch tool. It doesn't work in all cases, but it does work in this case. So there we go. We've patched that up, and you can see that it looks pretty good. All right, let's talk about the last case here. Now, the last case is a bit of a tricky one. Once again, we've got a case where, by default, using sort of our best knowledge about how these tools work, we would go for a patch. But once again, it's going across this defining feature of the surface. So the patch tool just is not going to give us the results. It gets a little bit better than some of the other cases, but it does still flatten out. And again, we might need to use the analysis tools to take a look at this. You can see that the curvature comes in, it sort of disappears and it actually goes in the opposite direction. And then it comes back as it connects to that. We can see it with zebra stripes as we rotate this around. We can see that we don't have a really clean, crisp line that goes through here. This, again, this is probably one of the better cases, but taking a look again at the highlights or reflections, you can see it's crisp, it's clean, and then it sort of bows out and then it comes back. So this is telling me, once again, it's just not the right tool. Loft isn't the right tool either here, but it does give us a better or closer result. So let's take a look at Loft and let's talk about why it works, but why it shouldn't work. So Loft will allow us to go from here. We're going to have to select the plus to create a new profile because it is connected at this point, and we want to loft to here. We are going to use a guide rail at the bottom edge, and we do want to make sure that we use curvature, continuity, or tangency. We are driving that shape across, and you can already see that the highlight looks a whole lot better than it did in the patch. Now, the reason that this works is because of the way that Loft works. It's generating a surface based on the boundaries we selected. We're telling it exactly if we want tangency, curvature, continuity, or whatever, and it builds the surface. However, the reason this doesn't work is because it creates what's called a degenerative point. Now, if we go to inspect, turn on our curvature map analysis, this point is a problem. Now, if we bring the scale of this down till we see the rest of the surface is just this light sort of greenish color, you can see that corner is still red. This means a lot of stuff is happening in this corner. Now, this tells me that I am going to have a problem there when I take a look at things like reflections in the surfaces. You might be able to get away with it, but you are likely going to have some problems. The way that we get around this is basically we would cut this into a four-sided patch. That would probably be the best option. If you don't have that option, which you don't always, then you want to make sure that you get rid of that degenerative point. So we can do this with a rectangle, we can do it with a circle, we can do it with whatever. But there is a problem here as well. Now, the problem here is if we go to inspect and turn on curvature map analysis and show the curvature of the surrounding surfaces, we have a problem because the surrounding surfaces have this orange and red color, it goes to this yellow, and then it goes back up to this red color, and then it goes back to this yellow color. There's a lot happening in this area that the degenerative point lives. That means this is going to be problematic for us to patch no matter what we do. Now, because of that, if we patch or we cut further away from that triangle, then we're going to be changing what happens in this area. If we are going to just cut away just as tiny, as smallest amount as we possibly can, then once again, we're going to generate problems. So no matter what we do, we're sort of backing ourselves into a corner. Let's go ahead and let's just do it anyways and see what it looks like. We're going to use split face, select all the faces to split, make sure that we grab that triangle. This is our splitting tool. And then we're going to use delete. So we want to delete this face. We're going to select this face as well as this one. Just hit delete on the keyboard. We want to stitch these together, which will mean that our edge selection is going to be easier for patch. Grab the open edge. All the edges are connected. Give it curvature continuity and say OK. Let's go ahead and let's just stitch everything together. There are a couple of areas here that we don't have stitched. Let's make sure that we select them all. Grab that one there, and we'll just put all those together. I'm going to hit Control and 4 to hide my edges, rotate this around, and it doesn't look too bad, but there are definitely some issues in those corners. So if we turn on our curvature map analysis, you can see it right away. Let's go ahead and rotate this around. Let's view it from the top, and we can see the areas that are problematic and the areas that are okay. Let's go ahead and bring the other body back and let's include it in the selection. And let's just take a look and identify these areas. Now the design already had this section where it sort of smoothed out and then the edge continued. And you can see that we had a lot of curvature in this area. So that already was happening. And because of the location of that patch, it just sort of made things worse. We see areas of high curvature, high change in curvature, and areas of low curvature right next to it. And that's again because when we use the patch tool, it gives sort of equal opportunity to every section of that edge. So that means this little green section here, potentially the yellow section, the red section, this green section, they were all influencing the curvature in that small area. We can also see that we do have this sort of disjoint that happens in that edge. If we take a look at the other side, this design, this body had symmetry across the midline on the Y and then across the midline on the X. So you can see that it was smooth before we made that lofted patch. So once again, the best option here would have been to cut a rectangle and create a loft. This section here, you can see while it didn't look too bad in the reflections, it does cause problems. Now, this small triangular section here, that was a patch. That's obviously problematic. This one here, this was our loft, and we could potentially get away with this if we go back and play around with things like tangency. In this case, we'll go back to this feature. Let's go ahead and edit. And if we use tangency instead of curvature continuity, we might actually get a better result across that based on the curvature. You can see that it's not really ideal, but there are things that we can do to potentially work with that. This rectangular section here is probably the best. You can see that it's relatively close to what the original design looked like. There are some changes here. Once again, play around with tangency, curvature continuity. You might get a better result, but by far, that is the best situation we had. This one over here, that was a spline cut. That one is not horrible, but it's not perfect either. So I would say in sort of the order that we have here, the rectangular opening, by far the best. This one that had sort of a curvature continuous cutaway did pretty well, but we did still have to patch those corners, which have their own inherent problems. Once again, that patch is giving sort of equal weight to everything, which means that anything that we have here that's green and red and yellow, it's all going to have influence. The next one that was, sort of problematic was the one that had multiple sides. Now, again, probably the best solution is to cut away a little bit more surface, make it a rectangular cut, and then just do a loft from the starting profile to the ending profile. The worst case was the triangular section. Now, the triangular section, the patch didn't work because that feature that we're trying to sort of carry through the design, it didn't work with the loft because it had that degenerative point. The loft was sort of bunching up in that corner, and that's universally true if you're lofting a triangle. If you're lofting a triangular opening, a patch, you are always going to get that degenerative point just by the way that the loft tool works in any CAD software that I've ever used. And to make things worse, because we had a lot of curvature change in the area where that degenerative point was, we made it worse by having to patch that area because, again, it's taking into account all the curvature along that edge, and it's sort of giving it an equal chance at affecting the curvature. So the takeaway here is that the universal sort of rules that we live by, the 4 side, we're going to go directly for a loft. The 3 or more than 4 side, we're going to go directly for the patch. Unfortunately, isn't always true. It's always going to be based on curvature. So when you start to work on your designs and you think about these decisions about which tool you're going to use, you need to think about not only the inputs that we have, things like the number of sides that we're dealing with, whether it's creating a brand new surface or patching something, but then we also need to think about the geometry, the shape. If we are patching a surface, is patch actually going to work for us? Now, in this case, if we were patching this section right here in the middle, it would be perfectly fine. If we were patching something on this mostly flat section, it would be perfectly fine. And that's because all of the edges have similar curvature inputs. All of the edges are either convex or concave, and they're very gradually changing. Whenever we have to cross over edges that have a more drastic change in curvature, in this case where we've got more of a stylized edge or a line, or we have convex and concave curvature in multiple directions. If we have our UV curves, which are the curves that are wrapping across the surface, when we take a look at those ISO curves or those UV curves, when we have them in multiple directions, that is going to be problematic for the patch tool. That's where we really want to look at 4-sided openings and using the loft, making sure that our profiles are on those edges with the biggest change in curvature so that we can drive that across that shape. Now, once again, these are not universally true. There will be exceptions to every rule, and it will be based on geometry. Now, the last thing I'll leave you with, and we're not going to go through this process because we're already almost at 30 minutes here. The last thing that I'll leave you with is how I would approach something like this. Now, if I, for some reason, had this design and all of this stuff was sort of hacked up, I would first want to know, does this design have symmetry? Do I already have a left side that's perfect that I can mirror to the right side? Now, if that's true, obviously use the geometry you have. Do I have geometry? So for example, this section here, I could have pulled from this section. This section here, I could have pulled from here, and so on. If it has symmetry, in this case, across the YZ plane, do I already have a section of surface that I can use and build in to it? If any of those are true, then use what you have to build in the surfaces. If they're not true, then obviously you have to work with what you have. Now, the last thing that I could potentially try here is to cut away this entire section and rebuild this portion of the design. Now, I can tell you that is easier said than done on this design, and that's because this design came from a form body. The form bodies sort of play by their own rules, and even though it's converted to a solid or a surface, it doesn't behave in the same way as generating that as a B-rep or a NURB surface from scratch. It just doesn't work the same, which means that if you're trying to build this whole handle section again, you are likely going to do it by creating some cross sections in what you do have, and then deleting all those surfaces and then lofting between those cross sections. That's likely going to be your best case scenario. You also could use that opportunity to change the shape as you go through. But I think that's as far as I want to take this topic. Again, I didn't really have intentions on doing another video that's taking a look at patch versus loft, but it's kind of a running theme with these surfacing tools is you have to kind of decide which tool is going to be the right tool for you to use, and it's always going to be subjective based on the geometry. I really appreciate the comments, the one from Janos, and I hope I'm saying your name correctly, about how he learned to use a loft for four sides versus a patch for three or more than four. I learned the exact same thing, and that is in most cases it's true. It's just not always true. Now, on the last video for the which is best video, I did pin that comment to the top because I do think it's important. I do think that it's always important that we think about this sort of general rules on how these tools can be applied, but also always in the back of our mind have an understanding on when they don't work and why they don't work. So that way we can make decisions on sort of how to fix or correct those problems. If you have any questions on this or comments about how you use these tools, how they work for you, how they don't work for you, or if you think I've misrepresented something here or maybe missed something, please let me know. We can always learn from each other. Everybody has different experiences with these tools. Maybe somebody builds different shapes and things that I don't build, and the tools work better in those environments. So I'm always eager to hear how people are using these tools so that way we can all have the best information. So again, if you have any questions, please let me know. As always, thanks for watching, and we'll see you in the next one.